Hello, welcome to my channel. Tonight I want to talk to you about my idea about how to view uh, the speed of light and the Big Bang and Redshift from the universe expanding. So, to put it pretty simply, most people seem to agree that the universe is expanding and it continues to expand and it continues to expand faster. There seems to be a point at which the universe began or started or expanded from, and from that point on, it gets pretty much faster and faster. The expansion does. And because space is expanding everywhere, seemingly, theoretically, this causes light itself to expand as well, which in turn causes it to redshift. It's kind of different from the typical redshift that you probably know about. When, like, for example, a car goes by you, it starts, how's it sound? It sounds like a meow, meow, like a race car or whatever. And that's the redshift in sound anyway. But the same thing happens with light. But actually, really quick, I actually thought of an interesting, I don't know, a dynamic that I never considered before. I don't know if other people consider this or not. They likely have, but there is a difference between observing an object that has been redshifted versus experiencing the object going by you. Where when the object goes by you, you experience this shift from a higher velocity to a lower velocity of what's the right word? I want to say repetition in waves, frequency, something along those lines. But when you observe something head on, I think that might make a difference in what you would make of it. So, for example, when you see a redshifted star, you're not seeing that light go by you. You are observing it come towards you, because that's what light does. It comes towards you. Always. I mean, it permeates the air too, or whatever, but you see what you see because light comes at you. This is why lasers are actually pretty cool, because you can see light. You can see the light without having to see it. But anyways, this is tangent. What I really want to talk about is what happens when you start viewing the universe and the expansion of the universe from the perspective of light. Light does travel pretty fast, but in the size and scale of the universe, I'm gonna sneeze. It's kind of slow in that it won't arrive, at least from our perspective, from one point to another without a given. Oh, geez, sorry. Oh, man. from our perspective, light takes time to arrive. But from light's perspective, it there's a funny quote I recently heard actually, where he says, "Light doesn't chase; it only arrives." So, what happens when you view the expansion of the universe from the perspective of light? What happens when you set the standard for velocity at the speed of light? So that, in other words, the speed of light is a metaphorical zero, and then you started measuring the expansion of the universe from there. In our point of view, it seems as though light is forever chasing the edge of the universe until it arrives at a certain point, place, and time on a given piece of matter. So what happens when you cancel out that redshift? What does the universe look like to light from that it was emitted from the beginning of time, from the beginning of the universe? We already can say that from the perspective of light, when you consider its journey, it seems as though it arrives pretty much instantly. But we also know that it doesn't. And I think it has more to do with how little and slow we are, instead of looking at light being as fast as it is. Because being as little as we are, I think it helps us actually see how slow light is compared to the size of the universe. But if we put ourselves in the shoes of a light photon, maybe the universe isn't actually as big as we make it out to be. And it's kind of funny too, thinking about how small light is. But then again, it has to be massless in order to travel the speed of light, for the most part, basically. And I suppose one way you could look at it is that the expansion of the universe actually accelerates the speed of light from a zero to a net positive, because it arrives quicker than it would have otherwise in a non-expanding, constantly sized universe. And then at the very same time, light as an entity, a beam, a wave, stretches as space expands. So it's not completely as though light even stays the same size. light that has been redshifted isn't just a shift in color, it's a shift in size, a shift in scale. But again, to the perspective of light, it never changed in the first place. So perhaps not even the universe, expanding as it is actually a hindrance to the real speed of light. It all has to do with scale, I think, in my opinion. But anyways, these are just some of my thoughts. Thanks for watching. See you.